Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are completing the radicals topic with the last topic, which is the reciprocal functions. So you know the reciprocal is that if you have like 1 by 2, so its reciprocal is 2. There's a simple thing you have to know, but we have to main focus of the graphs of this. That how can we make the graphs of any function if it's a reciprocal? So our main focus is for the reciprocal functions. So let's start with some example question like which the how the graph can be made with a simple thing. So consider the function f, fs is x, stretch the graph of y is equal to fx and its reciprocal function which is 1 upon fx. And the table of values show that y is equal to x and y is equal to 1 upon x. So y is equal to x is your simple function, is the original function, and this is your reciprocal function which is the 1 upon x. We have a table of values. You have to like in this like these are straight things. So if there is x is minus 5, so y is minus 5. So it's the same things you take. You get the same things if you like put that things. This is an easy thing. So 0, 1 by 10, 1 by 5, 1 by 2, 1, 2, and 5. And for the reciprocal one, you just reciprocal all the y is equal to x things. So it's going to be minus 1 by 5, minus 1 by 2, it's minus 1, this is minus 2, minus 5, minus 10. Now 0, the 0 reciprocal is the undefined. So you have to know that 0 reciprocal is undefined. Then you have 10, 5, 2, 1, 1 by 2, and 1 by 5. So you get these values and you have to test the graph of these values. So firstly, for the original function, if you make the graph of this, you will get like, if you put the things to minus 5 comma minus 5 right over there, then you have a minus 2 right over there, then you have minus 1, then you have 0. Now you have some points like minus half, which is 0 0.5 comma 0 0.5. These type of things you have, but I made some accurate points. So 0 comma 0 I put, then I put 1 comma 1, then I have 2 comma 2, then I have 5 comma 5. You have to make these things too. These things are B line on that same like this thing, and you will get the same line as a straight line in that too. So if you made that line and you put these arrows like this, so you will get this graph, and this is y is equal to x. Now the reciprocal graph. So in reciprocal graph, you have to consider something. So firstly, they've mentioned that 0 comma 0 at if you have a 0, if x is equal to 0 and y is equal to undefined in that function. So they're talking about that function. So for this function, this is undefined, which means this is the asymptote. So what is the asymptote? We will discuss that term, and asymptote is the term that we have to know for that. So as we have two types of vertical and horizontal. So at x is equal to 0, your y is undefined. So you have to know anything touches that thing from there. And when you make the rest of that points, you made like minus 5 comma minus 1 by 5. That points when you make, you will make like points over there and over there, over there, over there, over there. So I made some graph over there. So you get this type of graph. It's the curl kind of graph you get. So this type of graph you get, it goes to like touching the it's closest to the x-axis or closest to the y-axis, but it not touches that axis, because at that point our y is equal to undefined. So this is a asymptote, so that's why it not touches that thing. And the same with that thing. This is not very accurate, but these kind of thing you have to know that in this, and this is like y is equal to 1 upon x. So this is your reciprocal function graph like this. These are curved lines. Every question, if you like, when we combine all the functions of radical, rational, reciprocal, radical functions, when we combine that functions, you will get to know that how graphs do that. So if you have that kind of graphs, a curved graph like this, they involving the asymptotes in that. So this means we have a reciprocal functions graph. So you have to just know about this graph, and this is we graph do this because of we have to consider the linear functions too and the quadratic functions, so the same reciprocal graphs. So at that point you had that some more complex graphs. So we discussed that. So for discussing that, first we have to know some key terms. So Firstly term, which is asymptote, the line that the curve approaches. You can see the curve approaches to that asymptote, which is that, but it doesn't touch that asymptote, but never reaches as one of the variables approaches some particular value. So you have vertical asymptote and the horizontal one. So vertical means the occur at the non-principal values of a function. So vertical means that x-axis and horizontal means that y-axis. So we take something like our vertical lines are expected to express as the x is equal to a. A is something in that thing, a x is equal to 0. And the values are made the denominator of the function equal to 0. The denominator function, when we do the rational functions, we will see that the denominator stays that if x is equal to 0, the denominator is equal to 0, this will make our asymptote, vertical asymptote. For horizontal asymptote, we have to take some behavior of the numerators and denominators. We will discuss that when we do in the rational functions. This is the behavior of the graph for every large positive and the large negative values of x. And this can be expressed by the y is equal to a something. It's not equal to that thing, but when we take the equation of the vertical or the horizontal, we have to do the is equal to sign. Invariant points, the pointer remains unchanged when the transformation is applied to it. If you have an original point, if you have an original graph, you have a point of 0, 0. After the reciprocal or after any function, you will get a 0, 0. So this point never changes. This point remains the same, which means we have a invariant point in that case. So invariant point is that thing. So now we consider the linear functions and we have to consider some of this. Before starting this, I will forget to know that what are domain and range of this simple function. So for domain, you involve in that the x is not equal to 0. So the domain is not x equals 0 and x approaches all the real numbers. And for the range, y is not equal to 0 and y belongs to all the real numbers. So that thing you have to know, that both are not equal to 0 in that case. In linear and quadratic case, we have a different domain range. We discussed that. So we have a linear function thing over there. So we have fs is equal to 2s plus 5, which means that the reciprocal is 1 upon 2s plus 5. So determine the reciprocal function of this and this. So we have to determine the over there. So that 2s plus 5, which is y is equal to. Determine the equation of the vertical and the horizontal asymptotes of this. So for the vertical and horizontal asymptote, we have to consider this denominator value for vertical one. So that mean that 2s plus 5 goes to equal to 0 and you will get minus 5 comma 2. When you sign this, you get x is equal to minus 2.5, which is your vertical asymptote. You always consider the denominator. Denominator stays equal to 0, you will get your answers. Done. You have to find the x and y intercepts for this. In that particular case, you don't have any x intercept because you state that x is equal to minus 2.5. So when we actually made the graph of 2s plus 5, let's make the graph and make sure that plus 5, we made the first original graph. So plus 5 we have. So plus 5 is our y-intercept. So of the original function, not for the not for like reciprocal function. This is for the original function. So 5 over there, and we have like a slope of 2. So this over there, and it starts from the minus 3, minus 4. This over there, we have this, and this. Okay, so you made the line of this, and this goes like that, this goes like that. So this is your at y is equal to 2s plus 5. So for the next graph, so you can see that you have to have the asymptote of vertical asymptote of minus 2.5. So you have to make that asymptote of minus 2.5, which is right over there. You have to show this as the dotted line, and this at that you have x is equal to minus 2.5, which is your vertical asymptote, and at that point your graph doesn't 0. So at that point you have to make the whole of that, but the whole thing we discuss in the next unit, which is the rational functions. For this we have just made the line. For that's why that 2.5 is not our x-intercept, because it doesn't touch on that actually, but we not for now we made the whole, but for next unit you will see that we have to make the whole at that point. So there's no x-intercept, but we have a y-intercept of that. So the y-intercept we have to make for the reciprocal function, not the original function. So for the y-intercept, you will take like y is equal to 0. So you will get, when you solve this, you get 0 comma 1 by 5 something. 0 comma 1 by 5. This is your y-intercept, and you have to make the y-intercept in your graph. So is something over, if you made that, is something over that over there. Okay, so now you have to just accurate the things. So you have made the curve of this. So you have to, if you want, so you made the table of values like this, if you want, and you have to, because this is a number graph and you have to, but I made the like a random graph of this, like if over there, when this dot touches that vertical asymptote but is actually approaches that, it's like this, and from here to this goes like touching to the y-intercept, and this goes like that, and this graph is your y is equal to 1 upon 2s plus 5 graph. So that's actually, you have to make your graphs of the linear function. Let's move on to the quadratic function, and quadratic function is like more likely when we consider the quadratic functions in that. So state the reciprocal function of this, which is our 1 by h square minus 4. When we tabulate this, so when you like, this is like something you have to do, so it's h plus 2 and this h minus 2, and when it stays equal to 0, when you make this equal to 0, you get to your asymptotes, which is the vertical asymptotes in that case. So it's plus minus 2 when you make it is equal to 0. So at that point, you have an asymptotes. So like this over there. So at minus 4 over there, at plus 2 over there. So this whole points are the asymptotes of that. And the next thing you have, so the x-intercepts, so they don't have any x-intercept again. For the y-intercept, you have to put this in the your original function of the reciprocal. Like this function, you have to put your y is equal to 0 or x is equal to 0. When you put this, you get about minus 1 by 4, 0 or minus 1 by 4, which is like somewhat over there, I think. So this is for the reciprocal thing. But you have to firstly make the original function if you want. So for this original function, you will make the points. So minus 4 is your y-intercept of the original function. And you have to consider some points over there and over there. Make sure it touches on the minus 2 and plus 2 too, because this is original function. So it goes like that. From here, it goes like that. So like this. These are your points on that. But your original function, your reciprocal function doesn't touch that things. So you again made the tables values, and when you make, you will get this type of thing. So this doesn't not touch the, from here, it doesn't like touch the 1 minus 2, but it approaches to minus 2. So like this, from here to like this, and also you get some U-shaped thing over there, because you have this, consider that y-intercept 2, so you made that thing like that, and it approaches like that. So this is your graph for that. Make sure you have to measure this is your x is equal to minus 2, x is equal to plus 2, because this is all your asymptotes of that. So that's how you can make your reciprocal graph for a quadratic function. You have the x minus 4. You get any function. So that's all you have to do in the reciprocal functions. With this, we completed that unit. So this is the unit of radicals. We consider radicals, we do absolute values, we do reciprocal values, which are very important for this unit. And the graphs are very important. You do all this, many of the graphs in this, the piecewise function, the domain and range, intercepts, that all things we use in the rational functions too, and in the next grade 2, which is grade 12. So that's unit completion of this, and as soon as possible we started the next unit, which is the rational functions, which is again very important unit, and we now left with only 2 units, and we complete that unit by the end of May. So for this, learn using EduVibe, learn smart but not harder. Please like, share and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till this, you get it with EduVibe.